Hopefully it won't be the last one. Well, hi, everyone. I'm Alfred Gonzalez Trastoy. I'm a WebRTC engineer at WebRTC Ventures. And about WebRTC Ventures, we are a software development agency, and we provide real... Oh, sorry. Did you see the first slide? OK, so yeah, we provide real-time communication solutions, and these are some of the services we offer. And I've worked in development projects. I've done like open source media server projects and also CPaaS. I integrated contact center solutions, and I also AI features like this time, because I'm going to talk about implementing closed captioning and translations in a WebRTC application. So first of all, I must start with automatic speech recognition, which is a combination of processes and software that converts human speech into text, which is also called speech to text. And the opposite process is the speech synthesis that converts text to speech. And yeah, we could divide it into modes like batch and real time. For batch, you usually process large audio files. And it's more efficient than real time, but you don't expect immediate results. But with real time, you want immediate results. And what it does, usually you send audio as a stream to a service and get the results as text. And you can get partial results until you stop talking, and it will send the last result. And there are multiple examples of what you can do with speech recognition. You can build voice assistants. Also for transcription, like if you want to have a transcription of an audio file or a meeting, then you can review the contents. Also for compliance, if you have a contact center solution, for example, and you want to make sure that your agents are following the right script or that they are not saying anything illegal or inappropriate. And you could also use it to detect flaws in your business model or in your scripts, some of the issues that the customers may have. And also for closed captions, which is basically real-time transcription, which is what we'll focus on. And also to integrate it in IVRs to be able to detect the intents from the speaker, or to integrate it with LLMs, as we've seen from previous talks. And if you combine speech recognition with text translation, you get speech translation. And if you add also the speech synthesis, you could do a speech-to-speech translation. But we won't go that far, so we're going to do only speech transcription and translation. And yeah, why is it good to have speech recognition and text transcription? We get closed captions and transcriptions in multiple languages, which boosts the inclusivity and accessibility, because you can enable your service for people that may have language barriers. So you are translating from and to multiple languages, making it available for people around the world. You can also make it available for people with hearing impairment, because they can follow up a meeting by reading the transcripts. Also, if there's background noise on your end and you cannot hear the meeting, you can enable the transcription. Or the opposite, if the environment is too silent, like in a library, you don't want to enable your speakers. And if you don't have headphones, you could also use the transcriptions. And there are lots of services that you can use. But there are a few things that you must consider before choosing your service. The first thing is which features does this service support. So there are multiple features you can find, like transcription, translation, which we are focusing on, but also sentiment analysis, speaker diarization, also for assistant or sensitive data reduction, automatic language detection, all that kind of features. Then you have to consider also the accuracy of the speech recognition model you are using. And yeah, there are different metrics that you can use. For example, word error rate, which you basically compare real transcription with the transcription from the speech recognition service. And what you do is sum the differences, like substitution, deletion, and insertions that the model does, and divide by the number of elements, and just multiply by 100 to get the percentage. And around 5–10% is considered good accuracy, and around 20% is considered acceptable. Then you have to consider also the speed, which is how fast it can process the audio input, the price, and some technical aspects as well, like the programming language support, the documentation, if it's good or bad, data security, and also model training, which can help with the accuracy of your model. Because it's useful if you want to increase the accuracy for domain-specific or technical conversations. And also, if there's different audio conditions, you could also train your model, like different accents also. And well, I'm listing some of the some service options you have for transcription. You have the Web Speech API from W3C, Azure AI Speech from Microsoft. OpenAI has also the audio API with Whisper. And Amazon and Google have different services for speech synthesis, speech recognition, and also text translation. Then you have others that have additional features and focus on those also, which is Symbol AI, Assembly AI, DeepGram, and Beerhouse, which does specifically speech translation. But there are many, many more. And yeah, from the ones I listed, all of them have transcription. And translation, only a few offer them in their services, which are Microsoft, Amazon, Google, Beerhouse, and also OpenAI, but only translates to English. So it was not useful in our case. And there are free options as well. The Web Speech API is free and is available in the browser, but it has some limitations. And there are also free tiers. Like there are services that offer free tier options, and you may have a few hours each month for free. And then you have also open source options, like Whisper, DeepSpeech, Caldi, etc. And those you can manage and deploy and use for free, but you have to manage those. And yeah, I looked at some stats I found in the internet. So from Artificial Analysis AI, it shows the word error rate, the speed, and price for a few popular services. And the ones that offer translation that are here are Google, Amazon, and Microsoft, and they have similar stats. Then also I got some stats I found from DeepGram. They show the word error rate in different audio conditions, and also from Assembly AI, which they compare the word error rate in different languages. And yeah, of course, the stats they get, they differ from between each other, and usually they position themselves first, like DeepGram here it has the best word error rate, because the lower the better, and Assembly AI too. So depends how they depends how they get the data. And yeah, now we're going to talk about how to add the closed captions to a WebRTC application. I'll give a basic overview of our WebRTC application. We integrated it into a client's application, and most of it is on-premise. We use an open source media server and many open source things, and we provide conference meetings like end-to-end, also broadcast meetings where you can have multiple hosts, audio hosts, and also you can publish multiple videos. It has also a call center solution with IVR, and it uses speech recognition as well. And the inbound calls can be connected to meetings. Then you have outbound calls from meetings too, recordings, and more recently, the closed captions and transcription and translation. And yeah, the ideal scenario would be that you send the audio from your application, from the front end, to the speech service and get the transcription. And you could do it, you could send all the audio from all the users, like their outbound audio to the service, and you get the transcription from everyone. And the other option, which is not optimal, which is inbound, you could start the transcription and send the audio that you receive and the audio that you send it to the service and just run the transcription. But you would have duplicity of audio if there are two persons in the meeting that enable the transcription. You would be duplicating the transcription. So it's not optimal. And in our scenario, we have users connecting from web, mobile, and desktop apps, but also from phone calls. So yeah, we don't have this front-end option, so we must use a backend service for the phone calls. And we also have recordings. We want to have recordings with subtitles. And we want to synchronize it as best as possible. And for that reason, we decided to centralize the transcription by using a backend service that processes the audio that comes from the media server and sends it to a speech service. And we chose Azure AI Speech Service, which offers real-time transcription and translation. It has multiple language support because it transcribes and from and translates to 80+ languages, although some languages will be way worse than others. It has similar performance than others that offer translation. Then you have also that it doesn't store data on rest and it encrypts it on transit. You have multiple SDK options that you can choose. Also, the audio source can come from microphone, from an audio file, or from an audio stream. And it offers multiple, like support for multiple audio formats. You can customize the speech model because you can train it to increase the accuracy. For example, you could send like text with specific vocabulary to the model to train it, or also you could send audio with reference transcriptions to the model to increase the accuracy. And we are already using Azure also, because we are using it for the speech recognition for the call center solution. So that's also a thing to consider. And well, the implementation, as I mentioned, is to add a backend service that processes the audio and send it to the Azure AI Speech Service. And we had multiple SDK options to choose from, but the ones we considered were JavaScript and Python. The good thing about JavaScript is that we could use the same SDK from frontend and backend. And it offered the conversation translator class, which I'll explain later. And it's not available like in Python or other SDK. And the good thing about Python is that it does automatic transcoding using GStreamer, because it supports compressed audio, and JavaScript does not support compressed audio format. So yeah, the conversation translator class is interesting because it introduces this conversation concept on Azure. You can create a conversation and then send audio from the backend service to that conversation. And from the front end, you can connect to the same conversation and receive the transcriptions and translations. This way, we use the Azure infrastructure to do like the transcription translation and also to deliver the results instead of having to relay the results through our own infrastructure, which would add a bit more delay. But the other part is that we have to do transcoding. So we have to transform, not to transcode, the audio data, which is WebM Opus, to the required format, which is WAV with 16 or 8 kilohertz, 16-bit, and mono PCM. And we used FFmpeg. And well, this is a simplified example. So you get the audio data from the media server. You push it into a readable stream, and you set that stream as the source. And then you set the audio channels, the frequency, the audio codec, and the format. And the output is the audio in the required format by Azure. And you can already send it to Azure, and it sends it as a stream. One of the challenges was to think about the implementation, how to do it. And while I was working on it, I had some issues, although it seems pretty simple to use the FFmpeg and the Azure AI Speech Service. I had some issues being able to send it in the correct format and getting the results. Also, we are running the speech recognition in continuous mode, so it's always recognizing. And after long silences, it would time out and stop recognizing. So you could increase the timeout depending on your use case. But what I did is restart and stop mechanisms to be able to keep transcribing. And more recently, I had an issue with the cross-region availability. So you have the speech service running in, for example, in the US. And from Spain, which is where I'm based, I was, after a few weeks that we implemented this, I was no longer able to get transcription results from the front end. It would get a timeout. And I already contacted Azure about this issue. But yeah, the thing is that you are getting the timeout and you are not getting the results. So hopefully they will fix it soon, because this only happens with the conversation translator class, which I mentioned. The other options that you have do work. And it only happens from some countries, because I tested with other people, and from other parts of Europe, they were able to use it. So it's a bit weird. But yeah, if you are having the same issue and you want to solve it, you could just, instead of using the conversation translator class, you could use there's another one for translation, which is the translation recognizer. And then you use your own infrastructure to deliver the transcriptions and translations to the front end. Or you could keep using the conversation translator. And meanwhile, you can use your own infrastructure as well for relaying the results. And yeah, what we have is we increase the accessibility and inclusivity of our service, because we have real-time closed captions in our meetings. We have translation from and to multiple languages, also post-call transcription, and recordings with subtitles, although it's in the to-do list. And I'll show a live demo. Hopefully it works, but if not, I have a recording. So I created this basic example based on the Azure sample codes, and I modified it. So yeah, what I'm going to do is to enable automatic language detection, and it will be translating into multiple languages. So yeah, so now it should transcribe from English. Pero si cambio a hablar español, debería detectar el nuevo idioma. And well, and that's it. Just a basic example. Do you have any questions? I'm enabling.
There is a question over there.
Hi, thanks for your work. Did you try with some of the open source solutions about the speech to text? Because we were trying to do something similar, and if you already work on these projects, it could be really a good feedback to come back. Thanks.
Yeah, thank you for the question. We really didn't consider to use open source because we wanted something that worked more reliable from the start, and we wanted to have it as soon as possible. And yeah, we had different options, but we didn't consider. But after watching Enzo's talk, I had some ideas also to do something similar with open source.
Any other questions from anyone? There is one thing that got me curious, because you mentioned that you have a media server, but you didn't name it explicitly. I'm just curious, what did you choose to use?
Yeah, it's well, sadly we are using Curento, which is already dying, but hopefully we are able to migrate soon.
Did you already choose the media server to
No.
migrate to? Okay. All right. Any other question? If not, we've reached the point for having the final coffee break for today. We need to caffeinate you to have amazing after party. So we will get back. We're gonna start the last block at 4:35. Thank you.